My mega favorite number, and my favorite number in general, is 299,792,458, which is the speed of light in a vacuum. The speed light in general has really changed the way we think about physics, from classical physics to modern physics. And personally, physics has changed the way that I look at mathematics and made me really enjoy mathematics a lot more in high school. So I'll talk a little bit about the history of light and also my own personal um, experience with physics and maths. So the speed of light in a vacuum is denoted as c in physics and is a physical constant at this point and doesn't change. The first calculation for the speed of light was done by Danish scientist Ole Rømer in the 1600s, where he measured the time taken for light to travel from Io, which is one of Jupiter's moons, to Earth. And while Earth was at different positions in its orbit around the Sun. And he calculated a figure for the speed of light, which was pretty close. This was later refined by English astronomer James Bradley in 1727, where he observed light from two different stars and the time it took for them to reach Earth. One of the first Earth-bound measurements was done by French scientist Hippolyte Fizeau in the 1840s, and this was done from the toothed cogwheel experiment. And later, this experiment idea was also expanded upon by French scientist Leon Foucault in 1862, and he did this through the rotating mirror experiment, where he got one of the first very accurate measurements for the speed of light. Later, the values for the speed of light in a vacuum got refined more and more until in 1983, c became a standard international unit in physics, and the speed of light in a vacuum is now set to 299,792,458 meters per second. So, as I said, c is a physical constant. The speed of light in a vacuum never changes regardless of the motion of the observer. And this is sort of discussed in Einstein's theory of special relativity. In special relativity, it's time and space that can vary, and the speed of light is the one that stays the same. So also regarding the nature of light is questioning working out what light is. Is it a wave or a particle? Because it had behaviors of both. For one, it doesn't have any mass, because if it had mass, it wouldn't be able to travel at the speed of light. But at the same time, light also, for example, travels in straight lines, suggesting that it's a particle. So the idea that light was a particle came from Isaac Newton's corpuscle model in the late 1600s. And this was widely accepted for a while because Isaac Newton was a very reputable scientist and mathematician. And light as a wave was the alternative, and this was suggested by Christian Huygens wave model and around the same time. Quite a few years later, James Maxwell came along and sort of had a look at he explored the properties of electromagnetism, and he actually got a very, very close calculation for the speed of light using electric and magnetic constants. And which suggested that light had something to do with electromagnetism. And for quite a while in classical physics, light was defined as an electromagnetic wave with oscillating electric and magnetic fields. So a pivotal moment in physics came when we were thinking about what light actually is. And this started from Thomas Young's double slit experiment in 1803, which is very famous now. It's one of the first experiments that showed the dual nature of light. And the idea was that when firing a single particle of light through two slits, it would classically, we would think of it as going through either one or the other, but it was able to produce an interference pattern, which is strange because it's like the particle was interfering with itself. Mathematically speaking, this is a quote, mathematically speaking, what goes through both slits is not a physical particle or physical wave, but something called a wave function, an abstract mathematical function that presents the photon state, in this case its position. The combined wave function can then be used to work out the probabilities of where one might find the photon. And this is all from firing one photon through the slits. It produces an entire range of where that photon could be, which is the interference pattern. Max Planck later in 1900 had a controversial hypothesis which said that light is actually a stream of discrete packets of energy called quanta. And this is all leading into quantum physics. So at the time, this hypothesis was very strange. What the most widely accepted one at the moment was that light was an electromagnetic wave. And his theory was very strange and very foreign and seemed to kind of contradict a lot of things about that we knew already about the nature of light. But in 1905, Einstein wrote a paper on light and the photoelectric effect, and this utilized Planck's theory. And from then, I think he proved it, or he discussed experimentally the photoelectric effect and other properties of light, and he used Max Planck's hypothesis, and this sort of made us think about the nature of light and how it can actually be seen as both a wave and a particle, called wave-particle duality. So this is how light reshaped physics. Now, the modern definition for light now is light is a stream of discrete packets of energy known as photons that exhibit wave-particle duality. So they exhibit some properties of waves and some of particles. And this is a quantum definition of light. And quantum physics is now expanded way beyond light to other forms of energy and particles as well. The thing about quantum physics that makes it so different from classical physics is quantum physics is probabilistic instead of deterministic. Determinism says that we know the state of a system perfectly. We can perfectly predict the future of that state, how it will change, and we can also perfectly find out the past of that state and what it was like and how we got to this present state. But quantum physics isn't like that, and in fact says that we can't do that because there are fixed limits on what we can know about certain states, certain systems. So there are some videos that talk a little bit about this and helped me understand this. Well, not understand it, but helped me get a basic knowledge of what it's like. The first one is Veritasium's video, done in collaboration with Vsauce, on what is not random. This talks a little bit about determinism, and also some quantum mechanics video done by 3 Blue 1 Brown and Minute Physics on quantum mechanics basics. So my experiences with physics and maths, as of now, I am a student doing a Bachelor of Science in Education, majoring in mathematics and physics. So I am by no means an expert at any of these subjects. My understanding of physics is essentially like a high school graduate level. My goal is to eventually become an excellent high school and maths and physics teacher. And I've been inspired by various teachers and YouTubers such as Eddie Wu, 3 Blue 1 Brown, Veritasium, Minute Physics, and Mark Rober. So this is the part where I talk about my personal experience with physics and maths. In high school, my favorite subject was physics because I found it very interesting. I found it really fascinating, and especially when I got to the topic of special relativity, it completely changed the way that I saw a lot of things. Because time being a time being variable, for example, depending on the motion of the observer, it's a very strange concept, and at the time it completely changed the way I saw things. On the other hand, I saw math as mildly interesting. It was useful. There were some parts about it that were nice, but I didn't love maths that much. But that changed when I realized the connection between maths and physics. And I remember the one that in particular was the connection between calculus from the maths subject, and motion in one dimension from the physics subject. For example, if you have the velocity of something traveling in one dimension and you differentiate that, you find the gradient of the velocity time graph, you would get the acceleration And on the other, and going the other direction, if you have a velocity time graph and you integrate it, you look at the area underneath it, you're then looking at the total displacement of that object. And so this was the realization that led to my fascination and love of maths and physics. I saw pure mathematics as an abstraction of real world behaviors and patterns, and I think both seeing maths as something that's abstract and interesting in its own way, but also seeing how it can be applied, like as in physics, I think it's very amazing. There are some TED Talks by some of my favorite YouTubers that talk a little bit about this and kind of education specifically. One of them is Eddie Wu's video about mathematics, and the second one is done by 3 Blue 1 Brown, who talked about this as well. So that's why 299,792,458 is my favorite mega number. Here are some references, and here are the channels I mentioned that I would highly recommend. Thanks for watching.